A vehicle's suspension takes a tremendous beating. Fast starts, sharp turns, quick stops, and rough roads all affect suspension components. But the suspension is designed to perform and maintain its settings under all these conditions. That's not to say that the suspension doesn't need to be serviced. When a vehicle is out of alignment or suspension components are damaged, handling and riding comfort can be negatively affected, and tire wear could be accelerated. Hello and welcome to the June 1993 edition of Mastertech, Alignment and Suspension Update. In this program, we will discuss suspension and alignment on some of the newest Chrysler Corporation vehicles: the Concorde, Intrepid, Vision, New Yorker, LHS, and the four-wheel drive Jeep Grand Cherokee. We'll start by showing you each vehicle's suspension components. Then we'll talk about inspection and maintenance of suspension systems. We'll look at the symptoms of incorrect wheel alignment and perform some pre-alignment checks. Then we'll do a wheel alignment. We'll start by looking at each vehicle's suspension system. Since the front and rear suspension on the Concorde, Intrepid, Vision, New Yorker, and LHS use the same basic design, we'll use the Dodge Intrepid in our description of suspension components. Let's begin with the front suspension. The independent front suspension is a McPherson gas pressurized strut design, consisting of a steering knuckle, control arm with integral ball joint, tension strut, and McPherson strut assembly. Body roll is controlled by a stabilizer bar, which is connected to the left and right struts with stabilizer bar attaching links. A cradle supports the left and right front suspension components. The steering knuckle supports steering, brake, drive shaft components, and the wheel and tire assembly. It is attached to the vehicle by the control arm and McPherson strut assembly. The control arm keeps the lower part of the steering knuckle in place by linking it to the front cradle. The inboard end of the control arm is attached to the cradle by a pivot bolt through a rubber bushing. It's also attached to the cradle by the tension strut through an isolator bushing. The outer end of the control arm is attached to the steering knuckle by the ball joint stud, which allows rotation of the steering knuckle. The tension strut controls fore and aft movement of the control arm. It is attached to the control arm and the cradle and isolated by one bushing at the control arm and two bushings at the cradle. The control arm pivot bushing and the tension strut bushing are removed and replaced using special toolkit number 6644. The McPherson strut is a shock absorber and coil spring assembly, which includes spring seats at the upper and lower end. The upper part of the strut contains a pivot bearing, which allows the strut to turn with the steering knuckle. The McPherson strut is attached to the upper fender reinforcement with three studs, which are part of the rubber isolator top mount. It is attached to the steering knuckle with two bolts. The strut springs are different on each side of the vehicle, so they are not interchangeable. If you do have to replace the front springs, you will need special tool number L-4558A to remove and install the strut retaining nut. A stabilizer bar connects the front strut assemblies of the vehicle and keeps the body from leaning excessively in sharp turns. Stabilizer bar retainers on the cradle keep the stabilizer bar in position. A link on each side of the stabilizer bar attaches the McPherson strut to the stabilizer bar. If the stabilizer bar is removed, the cradle must also be removed. When replacing the stabilizer bar, be sure to center it in the middle of the cradle assembly, or it could come in contact with other suspension components. Those are the front suspension components. The independent rear multi-link strut suspension consists of a rear spindle, two lateral links, Chapman strut assembly, and a trailing arm. Body roll is controlled by a stabilizer bar connected to the left and right struts with attaching links. A crossmember supports the left and right rear suspension components. The rear spindle supports the brake and wheel and tire assembly and is attached to the vehicle by two lateral links, a trailing arm, and a rear strut assembly. The two lateral links connect the spindle to the crossmember and control side-to-side movement of the spindle. Lateral links have isolator bushings at each end. A trailing arm controls fore and aft movement of the spindle. It also has an isolator bushing at each end. The Chapman strut assembly is similar to a McPherson strut assembly, but it does not contain a pivot bearing since it does not need to turn. The Chapman strut is attached to the spindle with a pinch bolt. It is attached to the upper strut tower with 3 attaching bolts and isolated with a rubber top mount. Again, strut springs are different on each side of the vehicle and are not interchangeable. A stabilizer bar and stabilizer bar attaching links connect the strut assemblies, and rubber bushings isolate the suspension from the stabilizer bar retainers in the frame rail. 3 suspension packages are used in these vehicles: Standard, Firm Feel, and Performance. You may also see these suspensions referred to as Ride-Tuned, Touring Tune, and Sport. Each suspension uses a different damping calibration in the strut. The Performance suspension uses a different crossmember, lateral links, and bushings. LHS and New Yorker have a softer ride regardless of the suspension type. How do you suppose this is accomplished? They use longer, softer jounce bumpers than Concorde, and rear trailing arm bushings are voided or hollowed out rubber instead of solid rubber. The Performance suspension is identifiable by a 1/2-inch hole in the crossmember's rear vertical wall. To identify the Standard and Firm Feel suspensions, you must obtain the sales code. Vehicle suspension types and their corresponding sales codes are provided in this month's Mastertech reference book and in TSB 22-02-93. Not all vehicles are available with every suspension package. The Concorde is available with the Standard and Firm Feel suspensions. The Intrepid is available with the Standard, Firm Feel, and Performance suspensions. The Vision is available with the Standard, Firm Feel, and Performance suspensions. The New Yorker is available with the Standard and Firm Feel suspension. The LHS is available with the Firm Feel suspension only. Be sure you have properly identified the suspension package before replacing components. That's a description of the Concorde, Intrepid, Vision, New Yorker, and LHS front and rear suspensions. Before we go on to the Grand Cherokee suspension, let's test your knowledge. What is the basic difference in the construction of a Chapman strut and a McPherson strut? The answer is the pivot bearing. The Chapman strut does not contain a pivot bearing since it does not need to turn like the McPherson strut does. The Grand Cherokee 4-wheel drive front suspension is a link coil design consisting of a drive axle, upper suspension arm, lower suspension arm, coil spring, and dual action shock absorber. Front suspension side-to-side movement is controlled by a track bar, and a stabilizer bar minimizes sway during turns. The stabilizer bar is attached to the frame rail, and the stabilizer bar links are connected to the axle brackets. The drive axle is attached to the steering knuckle with an axle tube yoke, which allows the knuckle to pivot on ball studs. An upper suspension arm and lower suspension arm control fore and aft movement of the drive axle. The arms are bolted to the frame and axle through rubber bushings to control road noise. Coil springs are mounted to the unitized body bracket at the fender shield. A rubber donut isolator between the top of the spring and the bracket isolates road noise. The bottom of the spring seats on the axle pad and is retained with a clip. Jounce bumpers are used to limit the travel of the suspension. Dual-action shock absorbers dampen jounce and rebound. The top of the shock is bolted to the frame. The bottom is bolted to the axle spring bracket. The stabilizer bar is kept in position by mounting points on the frame rails. Mounting points are isolated by rubber bushings. Stabilizer links join the stabilizer bar to the axle brackets. The track bar is used to minimize front axle side-to-side movement. It is attached to the frame rail bracket with a ball stud and isolated with a bushing at the axle bracket. That's the Grand Cherokee 4x4 front suspension. The rear link coil suspension contains the same basic components as the front suspension. Attachment points are also similar to the front suspension. Now that we have described the two vehicle suspension systems, let's take a look at maintenance and inspection, right after a question about the Grand Cherokee suspension. The Grand Cherokee four-wheel drive front suspension is A, a Chapman strut design, B, a link coil design, C, a leaf spring design. The answer is B. The Grand Cherokee four-wheel drive front suspension is a link coil design. Ride and handling complaints indicate the need for a suspension inspection. These complaints do not always indicate suspension problems, and the receipt of a customer complaint should not be the only time a suspension is inspected. The suspension should be inspected regularly to be sure components are not damaged or worn, and an inspection is always necessary before doing a wheel alignment. There is no actual suspension maintenance, but steering components like tie rod ends, ball joints, and other grease fittings in the Grand Cherokee must be lubricated regularly. Grand Cherokee tie rod ends should be lubricated every 7,500 miles or 6 months. Ball joints should also be lubricated every 7,500 miles or 6 months. Begin your inspection of the suspension by looking at the tires. Wear patterns indicate different types of problems. Uneven wear patterns like cupping may indicate loose, worn, or bent suspension parts, faulty shocks, or struts. Uneven wear could also be caused by a bent wheel or unbalanced tires. Wear on one side of the tread or feathered edges usually indicate the need for an alignment. Wear on inner ribs is usually caused by overinflation. Wear on both outer ribs of the tire is usually caused by underinflation, although this type of wear may also be caused by high-speed cornering. And don't forget to also check that the tires are all the same size and that there are no shifted belts. If the tires are okay, continue your inspection by looking at the suspension components themselves. Before raising the vehicle, check the action of the struts or shocks by quickly pushing down on each corner of the vehicle. Good struts or shocks will usually stop body movement in 2 or 3 rebounds. Check the upper bearing of the McPherson strut for smoothness or noise by turning the wheel to the left and right with the engine running. After raising the vehicle, check all suspension components to make sure they are not bent or broken. Inspect all bushings to be sure they are not worn or distorted. And examine all steering linkage for looseness. If you suspect a problem, check the service manual for proper inspection procedures. Inspect tie rod ends for ball stud wear or corrosion, and check dust boots for damage, lubricant loss, or contamination. Check shocks or struts for an excessive amount of leakage. Small amounts of weepage where the shaft comes out of the strut is normal. Inspect for physical damage, improper mounting, and fastening. And don't forget to look for smashed or damaged jounce bumpers. Check ball joints for excessive wear. This is done with the suspension hanging and the tires off the ground. Grasp the tire at the top and bottom and apply in and out force. Look for any movement between the ball joint and control arm. If there is movement, the ball joint is worn and the control arm must be replaced. You should also check that the wheels are seated properly on their hubs and inspect hubs for looseness that may indicate a worn bearing. If you find worn or damaged parts in your suspension inspection, they should be replaced. When performing an alignment, the wheels, tires, and suspension must be in good condition. Now, get ready for our review question. What is one symptom that usually indicates an out-of-alignment condition? A, wear on both sides of the tire tread. B, wear on one side of the tire tread. C, wear on inner ribs of the tire tread. The answer is B. One symptom that usually indicates an out-of-alignment condition is wear on one side of the tire tread. There are several situations that may call for a check of wheel alignment. Wheel alignment is always done when parts that affect suspension and steering geometry have been replaced. Alignment checks may also be done as preventative maintenance. A customer usually requests a wheel alignment when vehicle steering characteristics, vehicle handling, or tire wear is not as it should be. However, improper wheel alignment may not always be the cause of these problems. For example, the curvature of the road surface, crosswinds, uneven weight distribution, or overloading can affect steering and handling. The condition of the tires and suspension can also cause difficult steering or handling. Symptoms of incorrect alignment are pull when driving, wander, feathered tire wear on one side, and tire cupping. Common handling or steering symptoms that are usually not alignment related are vibration or shimmy, pull to one side while braking, and high steering efforts. Before doing an alignment, be sure that the symptoms do indicate improper alignment, and then adjusting alignment settings will correct the problem. This means you need to perform a pre-alignment inspection. This inspection includes the things we talked about earlier in the suspension inspection. In addition, alignment must only be checked after tires are inflated to the recommended pressure, in good condition, and all the same size. The fuel tank is full, the passenger compartment and trunk are at their normal weight levels, and any suspension problems are corrected. After making the inspection and any adjustments, road test the vehicle to verify the customer complaint. Check for pull, noise, and vibration on a flat, smooth road. Also, drive over some bumps to check for worn shocks, worn bushings, or loose suspension parts. Finally, make some left and right turns to check overall handling response and for steering wheel return. When you have completed these steps, you can begin the actual alignment. Before beginning, you should also be familiar with some of the alignment angles you will be working with. Camber is the difference between the center line of the wheel and true vertical. When the wheel is straight up and down, camber is 0. When the tilt is inward, camber is negative. When the tilt is outward, camber is positive. The amount of tilt is measured in degrees. Excessive negative camber will cause shoulder wear on the inside of the tire. Excessive positive camber will cause shoulder wear on the outside of the tire. Uneven camber adjustment between the front two wheels may cause the vehicle to pull or lead to the wheel with the more positive camber. Camber measurements can be checked on both the front and rear wheels. Caster is the forward or backward tilt of the steering knuckle axis and strut center line when viewed from the side of the vehicle. Caster is 0 when the steering knuckle axis is straight up and down. Caster is positive if the axis is inclined rearward. Caster is negative if the axis is inclined forward. Caster is also measured in degrees. Caster difference from side to side may cause a pull or lead towards the side with the least positive caster. Toe is the difference in the distance between the front and rear edge of a set of tires. When the wheels are parallel to each other, toe is 0. When the front edges of the tires are closer together, the tires are toed in or given positive toe. When the rear edges are closer, the tires are toed out or given negative toe. Specs in the service manual are given for total toe, which is the sum of the left and right wheel toe settings in degrees. An acceptable range is provided as well as a preferred setting. In this example, a total toe of 0.2 degrees in must be equally split between each front wheel. Excessive toe out will cause scuffing on the inside of the tire. Excessive toe in will cause scuffing on the outside of the tire. Toe measurements are used on both the front and rear wheels. Thrust angle is the difference between the thrust line and the center line of the vehicle. The thrust line is determined by the direction the rear wheels are pointing. If the rear suspension is not damaged and the rear wheel toe is properly adjusted, the thrust line and the center line of the vehicle are the same. On vehicles with independent rear suspension, be sure the rear suspension is in correct alignment before the front suspension is aligned. This will ensure that the thrust angle or track of the vehicle is correct. We'll perform a four-wheel alignment right after our review question. When we are comparing the difference between the center line of a wheel and true vertical, we are looking at what alignment angle? A, toe. B, thrust angle. C, camber. The answer is C. Camber is the difference between the center line of the wheel and true vertical. The Concorde, Intrepid, Vision, New Yorker, and LHS require four-wheel alignment. Since their suspensions are similar, we will be using the Intrepid to describe the alignment procedure. Toe is the only adjustable angle on these vehicles. Toe is adjustable on both the front and rear wheels. On the front suspension, specifications are provided in the service manual for camber, total toe, and caster. On the rear suspension, specifications are given for camber, total toe, and thrust angle. All of these angles should be checked during an alignment, even though they may not be adjustable. You're probably wondering why you should check non-adjustable angles. Well, non-adjustable angles that are out of spec usually indicate bent or worn suspension components or frame damage. On modern alignment equipment, there are alignment heads for each wheel so that front and rear alignment can be measured as well as the thrust angle without moving the vehicle. In aligning the Intrepid, we will be using a bare four-wheel alignment machine. Before putting the vehicle on the alignment rack, make sure the turning plates are locked into position with the pointers at the 0-degree mark. Also, be sure the slip plates are in place for the adjustment of rear wheel toe. Drive the vehicle onto the rack, positioning the front wheels in line with the 0 marks of the turning plates. Be sure to chock the wheels so the vehicle will not roll. And place the transmission in neutral. When the vehicle is positioned properly on the rack, install the appropriate wheel clamp hooks and install a wheel clamp on each wheel. Then install the wheel units and the wheel clamp spindles. There is a specific wheel unit for each wheel position. They are not interchangeable from wheel to wheel. Now, with the main power turned off, connect the wheel unit cables to the wheel units. The long cables go to the rear wheels. The short cables go to the front wheels. You can now turn on the alignment machine and press Continue to reach the main menu. From this menu, select the alignment mode, which is four-wheel thrust line for the Intrepid. Then select the alignment procedure. We will use number 2, alignment, which begins with a run-out measurement. Run-out measurement allows the computer to compensate for variations in the position of the wheel clamps. To perform run-out, lift the wheels using the lifting device supplied with the alignment rack. Turn the wheel 180 degrees, making sure the wheel on the opposite side of the vehicle does not spin. Level the wheel unit with the bubble level. Then tighten it on the spindle. When the wheel unit is level, prompt the computer to take the reading. Now, loosen the wheel unit and turn the wheel 180 degrees. Level it and tighten the wheel unit on the spindle. Again, prompt the computer to take the reading. Repeat these steps at each wheel on a four-wheel alignment. Two-wheel alignments require only the front wheels to be measured for runout. The next step in your alignment is to obtain a caster measurement using the caster swing procedure. Before you do the caster swing, straighten the front wheels. Apply a brake pedal depressor to the brake pedal. Level and lock the wheel units. Remove the turning radius pins on the turning plates and lower all wheels onto the alignment rack. Before any measurements are taken, jounce the vehicle at the front and rear an equal number of times. This establishes ride height. Always release the bumper when it is at the down position. When the vehicle is prepared, prompt the computer to start the caster swing procedure. A caster swing meter appears at the top of the screen. A red pointer below the meter represents the position of the wheels. There are also 3 white range bars. A picture at the bottom of the screen shows 2 wheels and indicates the direction the wheels should be turned. Turn the wheels to the left until the red arrow moves into the center of the white range bar. When the arrow moves into the acceptable range, it turns white, and weight is displayed while the alignment readings are taken. Do not move the wheels while weight is displayed. Now, turn the wheels to the right until the arrow is centered in the range bar on the right side of the meter. Wait while the alignment machine takes readings. Continue as prompted by the computer till the caster swing procedure is completed. When the caster swing is completed, you will see the Display All page. Here we see the readings for camber, caster, toe, and thrust angle. Compare the measurements to the specifications provided in Section 2 of the service manual. Or, if specifications were entered into the computer, values that are out of spec appear in red. Values within specifications appear in green. If camber or caster are out of spec, suspension damage is a likely cause, and an inspection should be made of suspension components. If toe is out of spec, it can be adjusted. To adjust toe on the Intrepid's rear suspension, loosen the lateral link adjustment link jam nuts and rotate the adjustment links as required to set rear wheel toe to specifications. Do not exceed the maximum length dimensions of the lateral links. This measurement is provided in the service manual. If the thrust angle is out of spec and a rear toe adjustment does not correct it, a frame alignment is needed. To adjust toe on the Intrepid's front suspension, rock the steering wheel to the left and right with the engine running. Then center the steering wheel and turn off the engine. Hold the steering wheel in place with the steering wheel clamp. Loosen the tie rod adjustment sleeve jam nuts. Rotate the adjustment sleeve to align toe to specifications. Align one side at a time according to specs. As toe is adjusted, it is automatically updated on the alignment computer, allowing you to see the effects of the adjustments as you make them. When setting toe on the front suspension, do not exceed the maximum number of exposed threads on the inner and outer tie rod end. This spec is provided in the service manual. When toe is adjusted properly, hold the adjustment sleeve so it does not turn and torque the outer jam nut to 55 foot-pounds. When the outer tie rod jam nut is correctly torqued, the outer tie rod stud must be perpendicular to the socket. Again, while holding the adjustment sleeve, torque the inner tie rod jam nut to 55 foot-pounds. Again, if toe cannot be brought into spec, suspension or frame damage is a likely cause. We've provided you with wheel alignment procedures and covered alignment adjustments on the Concorde, Intrepid, Vision, New Yorker, and LHS. Now, let's try a review question before we look at the alignment adjustments on the Grand Cherokee. Toe adjustment on the front wheels of the Intrepid or Vision is done at what component? A. Lateral links. B. Tie rods. C. Tension strut. The answer is B. The tie rods have an adjustment sleeve for setting the toe on the front wheels. Toe and caster are adjustable on the Grand Cherokee front suspension. Specifications are also given for camber. By the way, there are no adjustments in the rear. The procedure for checking caster is the same as the procedure on the Intrepid. Incorrect caster angle can also be detected during the test drive by making left and right turns to see if the steering wheel returns to the center position unassisted. If it does not, incorrect caster angle could be the cause. If caster is out of spec, it can be adjusted by rotating the cam on the lower suspension arm. Whenever caster is adjusted, it is not instantly updated by the computer. The caster swing procedure must be repeated to determine the new caster angle. Changing caster will also change front propeller shaft angle. The propeller shaft angle has priority over caster. Refer to Group 16 in the Grand Cherokee Service Manual for information on measuring propeller shaft angle. The wheel toe position should always be the final adjustment, since changes in caster will affect toe. To prepare the vehicle for toe adjustment, turn the wheels both ways with the engine running. Center the steering wheel and turn off the engine. Secure the steering wheel with the steering wheel clamp. Loosen the adjustment sleeve clamp bolts on the drag link for right wheel toe. Turn the drag link sleeve until the right wheel is at the 0.12 degree toe-in position. Position the clamp bolts as shown and tighten to 36 foot-pounds. Adjust the left wheel toe position with the tie rod. Loosen the tie rod clamp bolts and turn the tie rod sleeve until the left wheel is at the 0.12 degree toe-in position. Position the clamp bolts as shown and tighten to 20 foot-pounds. That's the procedure for front wheel alignment on the Grand Cherokee. Now, for the final review question. What are the two adjustable alignment angles on the Grand Cherokee front suspension? A, toe and camber. B, toe and caster. C, caster and camber. The answer is B. Toe and caster are the two adjustable alignment angles on the Grand Cherokee front suspension. We hope that the information contained in this release will increase your knowledge and ability to satisfy the customer. For more information on suspension and alignment procedures, Chrysler Service Training offers a number of courses on suspension and alignment.